We are going to learn how to work with t-score. T-score. So, to understand t-score, it's working the same way as a z-score, which means we are working with the table. And that table is working with confidence level, C, okay, let's say 0.99, and working with degree of freedom vertically. So where degree of freedom is identified as n minus 1, sample size minus 1. So let's assume our sample size is 6. Okay. Before I go and show you how to work with this table, I wanted to tell you that t-score and z-score we use when we have normal distribution. With the difference, z-score we are using when our n sample size is greater than 30. Then we use z-score. When n is less than 30, we use t-score. We also use z-score if n is 30, less than 30, but population standard deviation is known. Then we use z-score. Okay. Now let's learn how to work with table. What do we have here? Level of confidence. We have one tail and we have the two tail. Degree of freedom coming in the column. So to understand confidence level, let's say this one, 99%, which means these tails, it's going to be our error. So it's going to be equal at error, it's going to be equal 1 minus this confidence interval, right? This area. Okay, but this will cover two tails, right? The tails error. But if we need one tail error, all we're going to do and divide by 2. So the table gives us all choices, all three choices. So I either can use level of confidence, or the level of confidence is not given, but given two-tail error. Here it is. We use this one. And if it's it's given one tail, we can use this one, right? So if we have here two tail and one tail and confidence, so I can take the confidence, let's say 0.95 for example, and add to two tail, I would get 100, right? Or this one tail multiply by 2 and add to level of confidence, I will get 100. Okay? So let's start working. We have confidence level 99% right here, and sample size is 6, which means degree of freedom is going to be 5. .32. So T critical in this case, let me clean this, we don't need any more. So T critical is going to be 4.032. All right, next one. confidence in level is equal 0.98, sample size is given 19. To find T critical, so to find T critical, first we need to find confidence level 0.98. Here it is. Yes, and we're going down till degree of freedom equal 18 because n is 19. So degree of freedom will be -1, which is going to be 18. Here it is. So if this comes down from here, there we go. So it's going to be T critical going to be 2.552. Okay. Let's do one more. C is equal 0.95 and S standard deviation is equal 3.5. Let me move a little bit more down so it won't look like it's a part of previous problem. Okay. S is equal 3.5 and N is equal 7. So here we are asked to find margin of error. The formula for margin of error is similar to z-score margin of error, with the difference instead of z-score we are going to use t-score, and instead of sigma which is standard deviation of population, we are going to use standard deviation of the sample over square root of n. Okay, so the only thing where we have S, standard deviation of the sample, we have n, sample size. The only thing we need to find T critical. So for T critical we are taking 0.95. Here it is. Take different color. 0.95, and we are going down all the way to n is 7, which means 6. Here it is. So we are hitting here 2.447. All right. So T critical is equal to 0.447. Okay, from here we will get margin of error is equal to 0.447 times 3.5 over square root of 7, and this will give us 3.2. That will be our margin of error. Okay, next one. What is given? So let me read you the whole problem. Construct confidence interval for the population mean using T distribution. Assume the population is normally distributed. Okay, and here we have given parameters. So C confidence level is equal 0.95. What else is given? X bar is given. It's an average of the sample, 13.8. What else is given? Sample size is given. It's an 8. And S, standard deviation of sample, is equal 3.0. So we need to find our mu, where mu is in the interval x bar minus margin of error, x bar plus margin of error. We do have already x bar. It's right here. Yes? Okay. So all we need to find is margin of error. Okay. We can do that. So first of all, let's find T critical, because we are going to figure out margin of error, right? Margin of error is equal T critical S square root of N. So T critical is equal, what do we have? We have 95% confidence level, right? (95% confidence level), and we have N is equal 8, which is degree of freedom going to be 7. So 0.95, here it is. Let me take this one off. Okay, 0.95 and 6. This is our 6, and this is our, no, I'm sorry, N is 8, so degree of freedom gonna be 7. 1 second. I was staring at previous problem. 7. 2.365 looks like. 2.365. Okay, so our T critical 2.365. All right, so from here, margin of error is equal to 2.365 times 3 over square root of 8. So margin of error is equal 7.095 over 2.828. Although I told you always use 6 digits, but when you have given number or t-score, in this case we have only 3 digits, then you can round up till 3 digits. Unless all numbers you are calculating, then you keep all 6 digits, okay? All right, so this is going to be equal 2.508. All right, so from here, what we need to find out, x bar minus error, x bar plus error. So x bar minus error is equal, x bar is 13.8, right here, 13.8 minus 2.5. Since my x bar is given and with 1 decimal, I round my error also till 1 decimal, and I'm getting 11.3. Next, I am going to find out x bar plus margin of error. Which is going to be 13.8 plus 2.5, and that is going to be 16.3. So our interval where mu, population mean, is possibly can be located, it's gonna be 11.3, comma 16.3. Okay. All right. Next one. Similar problem. Again, we need to construct the confidence interval for the population mean, mu, using t-distribution and assuming the population is normally distributed. Okay, let's see what we have here this time. So C is equal 0.98, X bar is equal 12.4, S is equal 0.61, and N is equal 19. So we need to find mu that is greater than X bar minus error, less than X bar plus error. As I always say, we always start solving word problem backwards. First, they want to know the mu, right, average. So therefore, we are writing down the formula, which is this one. So let's see, what is given, what is not given. X bar is given, but what is not given, that's margin of error. So that's mean we need to find margin of error. And margin of error, we already know, is T critical S over square root of N. Okay, let's find out T critical, how much it's gonna be. We have 0.98 confidence level, and degree of freedom will be 18 because N is 19. So 18 and 98. Oh, already have here. So it's going to be 2.552, right? All right, let's write down 2.552 multiply S is equal 0.61, standard deviation of the population. N is equal square root of 19. And that is equal 1.55672 over 4.3588. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's, well, 9, but beyond we have 8. Well, I guess I can leave it like that. And that is going to be 0.357. So from here, X bar minus error is equal 12.4 minus 0.4, and that is equal 12. And X bar plus error is equal 12.4 plus 0.4, that will be 12.8. Why I rounded up here? Because my X bar is given with 1 decimal only. That's why. So if any parameter is given in less decimal, then you round it up till that many decimals. So you don't want one number is 3 decimals, the other number is 5 decimals. So you just round up till as many decimals as you have. But if it's not given, if it's then when you calculate, you keep all 6 decimals. Okay. So the interval is going to be 12 and 12.8. Okie dokie. That was the fifth problem we solved. Let's move to next one. Let's see what we have next problem. All right. In a random sample of 6 cell phones, okay, I'm going to take 8 cell phones, so number would talk much better. I'm staring now at problem. In a random sample of 8 cell phones, n is equal 8, okay, the mean full retail price was $430.5, which is X bar was equal $430.5, and the standard deviation was $219. Okay, assume the population is normally distributed and use t-distribution to find margin of error and construct 90% confidence level, which is equal 0.9, margin of error and confidence interval for the population mean mu. All right, so we need to find margin of error first of all. So margin of error is equal t critical s over square root of n. So t critical, it's going to be 0.9 confidence level, and degree of freedom is going to be 7. 0.9, here it is, and coming down to 7. 1.895. Wait a minute, we have 1.895, okay, 1.895 times s is 219 and n is square root of 8. So as a result, we are going to get, let me see, 1.895 times 219, that is going to be 415.005, and divided square root of 8 is 2.828. So we divide 2.828, and the answer is going to be 146.74. Well, I can put 9 because after 8 is coming 5. So, okay, let me leave 8, 5. And after 5 coming 8. So it's, yeah, 8, 5, 8, 6. Practically, it's keep rounding ahead. Okay, we shall see in a minute. So, from here, X bar minus error, our X bar is 430.5, so we have only one decimal. So I'm rounding all the way to one decimal, and it is going to be approximately 146.8. So 430.5 minus 146.8, that is going to be equal 15 by 8 is 7. 9 minus 6 is 3. 12 minus 4 is 8, and 3 minus 1 is 8. 283 and 7. And x bar plus error, it's going to be equal 430.5 plus 146.8. That is equal 5 plus 8 is 13. Okay, 0, 6 and 1 is going to be 7. 3 and 4 is 7, and 5, 7, 7. So here we go. It's gonna, the average of the population is within interval 283.7 and 577.3. Okay, next problem. Let me solve next problem. What do we have here? In a random sample of how many devices? Of 5 devices, n is equal 5. In a random sample of 5 devices, the average repair cost was $65. Okay, and the standard deviation is $12.5. Okay, assume the population is normally distributed and use t-distribution to find margin of error that contains 0.95 confidence level. Okay, so margin of error and interval, same thing. Margin of error is equal to t-critical. Let me find 0.95 and 5, which is going to be degree of freedom is going to be 4. 0.95 and it's coming here for 2.776. Okay, so it's going to be 2.776 times s is 12.5 and square root of 5, right? So that's going to be 34.7 divided by 2.236067. All right, and if we divide, we are going to get 15.518. Okay, so x bar minus error, it's going to be equal 65 minus 16, because 65 is a whole number, so I'm rounding also till the whole number, so this approximately will be 16. We are getting 49, and x bar plus error, it's going to be 65 plus 16, and it's going to be 81. So the interval is going to be 49, 81. Okay, so I guess you will be fine solving such problems. And let me solve, let me see. Well, I guess I'll solve one more. There is 2 more left, so I'll solve them. Not a big deal. Okay. In a random sample of 5 people, the mean driving distance to work was 21.5. 21.5 miles, and the standard deviation was 6.1 mile. Assuming the population is normally distributed and using the t-distribution, a 95% confidence interval, a 95% confidence interval for the population mean, mu, is given. So mu is given. It's within 13.9 and 29.1. Okay, and the margin of error is 7.6. Through the research, it has been found that the population standard deviation of driving distance to work is 6.9. Population standard deviation, so instead of S we are using sigma, is 6.9. Okay? Using the standard interval for the population mean, it means this standard interval for the population mean, calculate, wait a minute. Through research, it has been found that population standard deviation of driving distance to work is 6.9. Okay, using the standard interval for the population mean, mu, standard normal deviation is standard deviation, okay, is known, and find the margin of error to construct 95% confidence interval for the population mean. Okay, so everything is given. We need to find build 95% confidence interval. All right, let's do it. To solve this problem, to find interval for the mu, I want to invite your attention on sigma. Given sigma 6.9. What does that mean? An n score, meaning sample size, is less than 5. If you look at the very beginning, what I said, if sigma is known and sample size is less than 30, then we are using z-score, okay? Which is precisely this case. Sigma is given. That's a standard deviation of population. And sample size is given 5. So what do we need to do here? We need to use z-score table, right? So to use z-score table, all right, so we need to find 0.95, which is going to be our positive z-score, and we'll get here 1.9, here we get 0.06. So z-score will be, z-critical will be 1.96. Okay, once we have, we can find margin of error. So whatever is given, it's given just throwing numbers for us. So for this sigma, we need to find its margin of error 7.6 is given for this standard deviation. But we need to find error for this standard deviation. Therefore, margin of error is going to be equal z critical sigma over square root of n. Z critical 1.96. Here I have the sigma 6.9 and the square root of 5. Okay? So square root of 5 is equal, has to be 2.4 maybe? We'll see. 5 square root 2.23. So this is equal 2.236067977. So it's practically coming 2.24. We shall see. And then 1.96 times 6.9, that is going to be 13.524. Okay, we have 3 digits here on the top, so I'm rounding here also till 3 digits. It's going to be 13.524 over 2.236. So divide by 2.236 and we get 6.048. So that's our margin of error. All right. So from here, what we'll do, our x bar, we need to find the interval, right, where population mean is. X bar minus margin of error, that is equal 21.5 minus, since it's a 1 decimal rounding till, so if 8 round 5, it's going to be 6.1. So it's going to be 15.4. And x bar plus margin of error, it's going to be 21.5 plus 6.1. And it's going to be 27.6. And there we go. We got our interval where population mean can possibly be. Okie dokie. See you at the next lecture, or I'm sorry, recording solving of problems. All right.